session tomorrow morning as well, before we start on book 4, which is the bigger book. So nice and easy day today, nothing too drastic at all. Let's see how we get on. Right, let's just check where I am. Okay. Right. Okay, anybody got any questions before we start on the next section of power plant installation? Fed and watered again. Ready and raring to go, as they say. Okay, right. Let's get this thing ready to go. Right, so power plants. Again, power plant itself is the engine. Let's go back there again, sorry. The power plant itself is the big the lumpy bit. We stick to the wing, goes spinny, goes fast, gets us up in the air and that sort of stuff. But again, the gas turbine is there's only part installation. We've got the cowling doors, we've got where it's attached to, the brackets, the mountings, the cowlings, the pylons, etc. Depending on the type of aircraft we're working on. Jet pipe, accessories, thrust reverse, all that again. And location can make it awkward or easier to work on as well. Oops, sorry, does that come back in? Grab it. Okay, so we're going to look at all those little bits and pieces as well. But again, where the engine's fitted, it's got installation for certain basic provisions. We need to be able to supply, you can see here, in this example, we've got an under-wing aircraft. Okay, so the engine is attached via what's called a pylon. So we need to be able to transmit electrical cables, fuel cables, air cables, all the connections required to provide power to the engine, and indeed a method of fixing and removing the engine as you see fit as well. Okay, now depending on the type of intake, depending on the type of the aircraft, the exhaust and that sort of thing will determine the type of engine gets fitted to the aircraft itself. All right, so cowlings, they can be made from aluminium alloys and that sort of thing. Where factory section, you might have slightly harder bits, and you know, we have things like titanium reinforced casings on exhaust units and all that sort of thing. Again, depends on the size of the engine, depends on the accessibility, and obviously safety is more paramount. The bigger the engine, the bigger the potential problems. Like you can see here, we've got these big doors, the cowling doors open for access. Small aircraft, small engine, not as bad. Imagine obviously you're inside there, you're not adhering to the proper procedures, things can go wrong. So again, safety is paramount. Make sure we conduct it all maintenance in accordance with manuals and safety as well. Now, like the example showed you there, the engine mountings are crucial. Engine mountings are obviously part of the engine, and we've also got the aircraft mountings, which must stay with the aircraft and don't go back to the actual engine side of things. Mountings themselves can have a forward one. It all depends on the type they've got, but they've got to be able to transmit the thrust to that airframe and developed by the engine, and you know, support the engine at the same time. You can actually see an engine fitted to an engine wing or side fuselage. There's not actually too much to it. You'd be actually quite surprised that is that all that holds an engine on. Okay, so it is quite surprising when you actually see what only holds an engine on. Depending again on the size of them, the type of them, you have various brackets, various connecting beams. It could be a side-mounted engine, it could be a tail-mounted engine, pod-mounted, and so on and so on. Again, it all depends on the aircraft type. Wide variations, temperature. So again, you've got to allow for thermal expansion. So again, if things are too tight or too slack, that can cause problems. And you usually have 3 or 4 mounting points, sometimes a saddle-type forged beam, and connect through what's called fillets. The beams connect to engine mounting points, links and thrust trunnions, and must be connected to provide radially and obviously actually thrust mounts as well. Okay, so we have to make sure it's fitted in the right way and keep it proper. Pylon ones, well, pylon ones like the previous photograph we saw, the engine is underslung to a fillet or pylon. Okay, you must take great care, especially bigger engines. You can't just put on that. There's a button on Facebook or YouTube where they were fitting, I think it was aircraft investigation actually, they were fitting an engine with a forklift. Well, a forklift, yeah, it's great lift, but it's not very smooth, it's a bit jerky. So what happened, and because the crane wasn't working properly, they used a forklift and they bumped the mounting into the actual structure and actually cracked the structure. So when the aircraft went flying, they lost an engine, unfortunately lost the aircraft. So again, proper tools, proper equipment, nice and slow. Some engines, you have to put a weight on there because the engine is so heavy, you can't physically feel the weight of the engine. That you rely on the gauge to tell you when the engine is in the right position. So you can put the bolt in, torque it up, and so on and so on. Okay. Strongest part of the engine, use compressor cases and turbine mounts, and there'll be allocations for when they're in a cradle or a cage as well. Obviously, when you take these engines out, it's going to be crucial that you inspect them, and sometimes the links that stay with the engine side of things, like these ones here, they would actually go off to be NDT'd. And even if they look okay, they might have been subject to heavy landing and such like, so they actually get sent away, NDT'd, and you'll get a set of replacement ones to fit as well. And also have spherical bearings in there too, so there's quite a lot of bits and pieces going on. If you've got forward mounts, again, depends on the actual type of the aircraft you're working on. So actual mounting points in the engine are usually located at the front of the compressor, as I said, rear and exhaust, still turbine casing, and the forward mounts generally carry engine thrust, vertical and side loads. So this coming in there. Okay. So yeah, forward mounts, make a note of their highlight in your book. It's probably the same as some of your books you've got already. I was going to ask you, any word on getting the new books? Have the new books getting issued to you soon? Have you heard anything? Anybody?
Yeah, I got.
Yeah, you got new books, have you?
Yeah, I got new books.
All right, so the April 2020 books, yeah. So that's fine. If you manage to get them all printed out, that's good. So you can start highlighting the bits and pieces we've gone over already. The rearward mounts, or aft mounts as they're sometimes called, restrain the engine movement in all directions except forwards and backwards, or fore and aft. That's why they're called the aft mounts. They allow for longitudinal expansion. Okay, longitudinal expansion. So that's from the nose to the tail. Main mounting, bolt or tring assemblies may have what's called spherical bearings, and they allow for expansion and torque. And in some cases, some of the rubber bushings to absorb vibration. You tend to find that on APU and some turboshaft aircraft. Now, the one I just mentioned before we went to lunch there was an instance where the pilot of, I think it was a twin prop aircraft, they were flying from Scandinavia, and they put the APU on for, there was a reason going on it, whatever it was. They decided to put the APU on, but unbeknown to them, there was a crack in one of the mounts of the APUs. And then just by chance, there was an aircraft going the opposite way, a bit of turbulence, and it caused the APU to rotor. Now, they didn't know this, obviously. And unfortunately, the APU came off its mounting and it ripped the tailplane off, and unfortunately, they lost the aircraft. So, although the pilot put the APU on in flight, not meant to, there was a reason he put it on for whatever reason. But again, it proved that obviously maintenance, timing, how long a bit of equipment should be in storage on an aircraft was obviously paramount. So again, take care when you take the bolts out and nuts out and the mounts, make sure you look after them. Inspect them, if in doubt, go and get them checked out. Anti-vibration mounts, as I say, sort of hard to see in the DAG at the moment, but support struts, some rubber in between, okay, and that helps the, obviously if you have metal against metal, especially in a turboprop aircraft, there will be a lot of vibration possibly moving about. So it is there to support them, all the good play. Most common on helicopter engines, maybe part of the drive shaft from the engine, also part of the engine mount assembly. So anti-vibration mounts will have those, and the anti-vibration washers, like we saw, the little thin ones that we showed you earlier as well. Pylons and struts, well, they determine where an engine is fitted. A pylon and a strut is usually underneath a wing. So of the same meaning, but may be found in use in manuals and other publications. So pylons or strut means it's pretty much the same thing. They tend to be aerodynamic as well. So again, you have a covering over there. Inside the actual, if you take the main cover off, which is obviously for aerodynamics, you'll see a fuse link, an upper link, fuse pins as well, diagonal braces, and the main strut or pylon, and with the engine will locate into the front and rear points. All right. Now the reason we've got fuse pins, we've got fuse pins in there. Well, what are fuses designed to do? Normally, what would a fuse do? On anything? If you've got a fuse fitted,
pop on,
yeah, it's going to break or blow. Something's blow, yeah. Well, why do you think we've got fuses? Mechanical ones, that isn't in electrical ones. Why have we got mechanical fuses in the supporting? We've got a big heavy engine. What on earth would we need a fuse for? Why have something that can break on purpose?
Yeah, if unbalanced installation of engine.
Not installation.
Or heavy vibration.
High vibration, possibly. Heavy landings and in aircraft emergencies. So examples like this one. If you've got a gross overload or a failure sequence, it's going to snap away. All right, so that'll snap away. If you have a heavy landing, rather than damage all that excess torque or the G pulled by the engine pulling down the wing, that could overstress the wing. So what can happen is the fuses can break and the engine rips away. Saying that, there's a good chance the engine's probably going to rip up and break the actual wing. Likewise, maybe a heavy landing, or the wheels have not come down. They've a bit of a crash landing, a perfect crash landing, where they managed to land safely, but the wheels were kept up. The links can also break the opposite way, and the engine comes up and saves more damage to potential aircraft. Okay, I think that's probably the last thing you're worrying about, but if it can help protect the aircraft, then fine. I do have a photograph on my other PowerPoint to make sure. Main loads usually carried at 1 or 2 points of the engine. Again, you can just see there's the sports strut. So you can see the size of what type of engine is this? Is it high bypass or low bypass?
Of course, a high bypass.
Very high bypass, yeah. Look at the distance there to there. Okay, from the core engine down to the fan. I mean, that's a fair size of. You can just see in the middle the VSBs and bits and pieces. But yeah, in there you'll have your fuses, and obviously there'll be a cowling, the doors that go around that as well. So loads are usually carried at 1 or 2 points on the engine. And the points are known as trunnions. And you want to highlight that. Trunnions. Oh, excuse me. And my wife got the phone. 2 seconds. Hopefully it's not an emergency. Right. That's mine. Okay. Right. Back to there. So yeah, trunnions. Maybe attached to intermediate casings, okay, or the nozzle box assembly, right, or nozzle box assembly, just the strong structural parts there. All right. Again, they allow for engine expansion.
We have lost the PowerPoint.
All right. Sorry, what's happened there?
Only a handsome man video.
Back on again. Let's see, where's it going? Bang, there we go. No, it's not done there. Why has that come off? Try again. There we go. Is that there?
Yes, thank you.
Back on, okay. Was it just that last slide that went off, was it? I didn't notice it go.
Last slide only is okay.
Just last slide, okay. I'll go back just to make sure we're okay. Don't know why that did that, never touched anything there. Okay, let's go back. That one, yeah? Everybody see this last one? That's the one I've got there now, with the pylons and struts. Yeah. So everybody happy that the fuses on the pylons and struts? Okay. Yeah, the mounting brackets themselves. I'll just get that again. Peter's been a bit funny now for some reason. What's it doing now? All right. get back to it. Yeah, mountain carries engine weight, share of flight loads, etc. Okay, so that's its main purpose. But actually, when you see it fitted to a structure pylon, there isn't a lot there. It doesn't actually. You think the size of engine, it would need more support, but it's very well designed, very cleverly designed. So again, pointing on strung ends attached to intermediate casings, or indeed nozzle box assembly. Turboprop engines, they tend to have some sort of cage, again like that. So the cage itself is fitted to the aircraft wing, and then the engine will slide in and fit against a couple of mounts, maybe one either side there, and maybe another one at the back or underneath, depending on the type. Forward, tubular steel frames, again securely strengthened points at the structure. Again, by having the sort of zigzaggy effect of the cage, again, quite a heavy engine, but because of the design of the cage, it supports it all there. So again, tubular steel frames and accessories ready for the craft structure there. Okay, that's a typical turboprop. Now the term ECU. An ECU is an engine change unit, and that also another way of describing an engine and its accessories ready to fit to the aircraft structure. So you'll get an engine from the engine bay or wherever it is from the company. It'll arrive on a transportation stand, and depending on how many engines the aircraft has, and depending on which side it is as well, you may have to do what's called dressing the engine. Now, what we mean by dressing, we don't put in clothes. It means we remove and enable the ECU to fit either the left-hand side or the right-hand side of the engine. Okay, so you might have to fit things like cowlings, some sort of rephrasals, some sort of doors that are positioned purely outside the core engine, the main engine. It can be fit any side, but there's accessories that go around at the doors. They are sided, as we call it, so it'll be left-hand side or right-hand side. So that's the term what I mean by dressing the engine. Okay, and obviously when you've seen this photograph here, health and safety back in those days, you've got guys working on engines, you've got other people walking about. Yeah, you know, make sure a big engine like that, you certainly have a corner area to prevent other people walking in. So again, this is you see the guy standing on top of the line. No safety equipment at all. Yeah.
Excuse me, we are not seeing the pictures here. Is there any problem?
The one on the slide.
Yeah.
No, we can see it.
Where my laser is now, yeah?
Yeah, we can see the 747.
Yeah, that's what I'm on about, yeah. Anybody not seen that?
Khagendra, I have not seen yet.
Maybe your internet problem.
Okay.
Yeah.
Yeah, you can leave and join again.
Yes, it's probably the easiest thing to do. If you're not seeing anything, just go off and come back on again. Everybody else okay?
Okay.
Yeah, just let me know if you're not seeing any PowerPoint at all. At the moment, it's saying it's going out the way. I'll wait till it joins back in. Comes back in. But yeah, looking at the photograph there, you can see the man here just standing on top, no helmet, no safety overalls, no nothing, no sling, and quite a long way down. Okay, but that's back in the 50s and 60s. You know, you're looking at 60s sort of there, so totally different. But nowadays, you have staging, support, fall restraint systems, and all that sort of thing as well. So make sure when you're fitting engines, health and safety. All right. But again, we're going back to dressed engine. It just means we are positioning the engine to fit on that side of the aircraft. Again, it could be at the top of the aircraft, at the fin, it could be in the fuselage, left or right hand side. So that's when we made dressing it. The engine is ready to go. When it arrives at you, you just have to put the aircraft parts back onto the engine. Okay. A thrust strut. Now, a thrust strut again joins the engine, and side-mounted engine. A thrust strut may be used between. Now, this good one to highlight is between the front and rear mounting beams, and what it does is it spreads the thrust loads evenly. Okay, it doesn't support. It does sort of support, but to a degree, it spreads the thrust loads evenly. So that would be a typical side-mounted engine. Now, it could be external. of the fuselage, or it could be internal to the fuselage. One aircraft I used to work on, it was actually part of the fuselage. Okay, so depending on where the position is, depending on dressing, and depending if it's got a thrust strut as well. But the main point is to spread the load between front and rear. Okay, it's a good one to highlight there as well. Okay. Inspection, engine mountings. Yeah, definitely need to inspect them and just take them off and put them to one side. They're under a lot of stress all the time. Okay, so we need to check them. Inspections, what's going to be, when you're going to carry out inspection? Well, put in detailed in the maintenance manual. At every engine removal installation, definitely. Pre and post removal. So you'll remove them, you'll check the mountings, you'll check the aircraft side, you'll check the engine, you'll check especially the bearings, the bearings should be nice and smooth. One of the engines I worked on, you'd have a forward mount, which is bolted from the top, and you'd have a rear mount, and then the side linkages, they were just pit pins, and the pit pins would just be a nice, smooth, positive feel as they pushed them in, pushed them out. If it felt wrong, then something wasn't right. You should never, ever have to hammer any mount in there. If you get a hammer somewhere, something's gone wrong, okay? Something's been damaged already. So there should be a nice, positive feel with the hands only. Everything else is torque tightened up. Again, you might need a torque multiplier, could be a big engine, that sort of thing, so just be very careful with that. Okay. Heavy landing check is carried out. Yeah, it's going to be a lot of checks, not just on the engine. The whole aircraft's going to have a lot of checks on it. But again, apart from the engine, heavy lines, compressor damage, turbine damage, oil systems, magnetic chips, etc., you might have overstressed the mountings. And the fuses, they might have not fully gone, but might have been stretched so much that one might have cracked. Okay, so they might have to be replaced as well. There's a good chance of being heavy landing. I mean a severe heavy landing, because a lot of aircraft have a couple of heavy landings here and there. But a one where they've really bounced the aircraft, it'd probably be worthwhile removing the engines and just replacing the struts anyway as a part of precaution. Because if they've been overstressed, there's a good chance maybe the next landing, maybe not quite severe, could possibly blow the fuses. And then last thing, you've got engines rolling down the runway. It's not very good. Engine vibration is reported. Yeah, it could be something simple as that. It could be the spherical bearings and linkages could be damaged or worn out as well. Again, you'd be checking that when you take them out as normal. So some inspection you'll carry out will be visual examination around the mounting bracket, surrounding structure, corrosion, distortion, cracks, pulled rivets where the mounts are actually made on the aircraft, bolts, special fasteners, check for correct torque loading, and also correct locking. Again, you'll do that as you fit the engine, but also when you remove the engine, you might have to replace the bolts, even though they look okay. It could just be part of the checks. And the trunnions, again, checked as fast as possible for obvious security of attachment and any obvious faults. Most of the damage that occurs is when you're fitting an engine. Okay, that's when poor engineering handling, not doing things correctly in line with the book, or getting hammers out when hammers are not required. Are very, very rare. I have seen occasionally a plastic hammer just as a little gentle persuasion where it was just a little bit, it wasn't damaged, but just a gentle just to get started. Once it went in, pushed in, fine. Because certain temperatures, if it's a hot climate, pit pins can be quite hard to go in. Sometimes we put them in the fridge to contract them, to put them in and let them expand normally. But again, maintenance procedures will tell exactly what you need to do for each specific engine. And I say, when you remove things, if it doesn't look right, it probably isn't right. Signs of overheating as well. Yeah, there's any maybe leaks from the engine that's been causing damage to the mounts as well. All become apparent. Okay, so once you've done inspections, you're looking for the limitations and structural damage in a member. Now, the member could be a strut, it could be a connecting rod, it could be lots of things. Now, when we look at damage, we think of things like dents. Now, dents are acceptable, can be acceptable, provided they're isolated with a set tolerance, smooth, so there's no, any roughness can cause fractures. Now, a dent is obviously damage, but it can be accepted up to a smooth amount. Must be free from cracks, abrasion, not exceeding 1/20th of the outside diameter of the tube, or not exceeding 50th of an inch depth of any face of square tube and not occurring in the middle third of the tube. Again, this is a general one. It will be more specific to the more type of aircraft engine you work on. But how could you measure a dent? How could you measure a dent in a pipe or a tube? How do you think you measure one? Any ideas? So you got a dent in a tube. How could you actually physically measure how deep that dent is? Any ideas? No. You could use a micrometer, so a depth gauge, a DTI, spring calipers, feeler gauges, a bit of masking tape with a small hole, ball in place, use a anvil micrometer, modeling clay sort of thing, something that can take indentation, and then you can measure that. Again, you'll get through experience, you'll be able to tell if that's in limits or not in limits. Bowing, what I mean by bowing is like banana shape, where a rod should be straight, but it's maybe starting to get a bit of bend on it, so that's what I mean by bowing. Using a straight edge and feeler gauges, not show up if there's any distortion. Stretch length thread, feeler gauges, a 3-point trammel can also be used. There's lots of different methods of doing it. Again, your maintenance manual will describe what tools to use and what the limits are as well. Remember the bowing of which does not exceed what's called the 1 in 600 rule. In other words, 20 thou of an inch per foot length, and can be considered serviceable. So what do I mean by that? So example, I've got a length of a connector is 24 inches. The clearance measured is 40 thou of an inch. So by using this little formula, don't worry, you won't get a calculating exam, but just be aware of the numbers. Okay, clearance measured by feeler gauge. So you'll get a straight edge, you'll put feeler gauges in, get a nice positive feel, measure the feeler gauges, and you'll get a reading. In this example, we've been told that there's a gap. That's what that's meaning, a gap of 40 thou. So the clearance measured by feeler gauge. So we'll put 40 thou in the top, and then divided by the length of the member. So there's the 40 thou gap, which you've been told here. There's the length of the member. So it's simply 40 divided by 24. Going back to module 1 maths, how do we do division? Get rid of decimal points. So 4 divided by 2,400, or we can cancel that down, reduce the fractions. Remember, making numbers easier to work with. So we get 1 in 600, or cancel it down is the same as 1 in 600. Okay, so it's within its limit. All right. Again, don't worry, you won't have to be. You may just be aware of how we check a bow and a member. You won't have to do a calculation in the exam. But just be how we calculate one by using feeler gauges and just the gap divided by the length. That's pretty much what it is. As long as it's within 1 in 600. So method of assessment dents is said there, using by a ball, micrometer, spring calipers, feeler gauges, bit of masking tape, a small hole clamp to hold the ball in place, etc. Also use a ball anvil micrometer, so it's got a little ball at the end of the micrometer, which we have a ball face on a spindle, so actually get into the depth of the dent. And again, the bowing, straight edge and feeler gauges, stretch line of thread, and also feeler gauges, and a 3-point trammel be also used. Again, these are a trammel is an old school type tool. But again, just be aware of these. Okay, moving on to cowlings. Let's have a look. Cowlings. Okay, right, cowlings. Cowlings are just the doors that surround the engines. Now, they do a lot of things. They allow access for you to get to the engine. They also surround the engine, because if we're flying the aircraft without these cowlings, well, they're not very aerodynamic. So they also provide an aerodynamic covering for the engine itself. Okay, so there's various types of hedges. Obviously, the bigger engine, like I said before, they are heavy. So be very careful of these. And you can see the breakdown. There's the obviously the standard engine intake. There's the aircraft intake. Okay, a Pitot Type 1. There's right-hand side, left-hand side, main core engine, and the exhaust nozzle, or common nozzle assembly, I should say, which is the aircraft one, which incorporate things like the thrust reverse. They'll be in touch there as well. You've got the pylon, the C duct. They're called C ducts because they make a shape of a C, hence the C for cowlings. Cowls, very importantly, do not open in high winds, small or big, because the bigger the ones, the more wind, they'll act like a sail, so they can potentially rip off. We used to have speed limitations of about 50 knots, 55 knots maximum. It depends on the aircraft again, but there usually are set standard limits for that. 2 people are required to open side cowls purely because of the weight of them. Again, some are manual, where you actually lift them up and then lock in position. Some are actually operated hydraulically. So again, be very careful if you open hydraulic open ones that the locks, the support locks are put in once they are open. Do not go into an engine bay with just the side cowls open on a normal support strut, because they could fail. You're supposed to put proper locks in position as well. Okay, be very careful of these. If these come down, especially the ones on the hydraulic pressure, they will keep going and you'll just get trapped and severely hurt. So be very careful. Just double check there. Yeah. C ducts, again, must have been working carried out in that region of the thrust reverser. Again, damage and injury could occur. Make sure your necessary circuit breakers should be tripped and placarded, especially on the cascade ones. The cascade ones, again, when they get activated, they slide back and forward. If you have power on, hydraulics on, or pneumatics on, and you're in that vicinity, not testing thrust reverse, not say having the engine running, but certainly got hydraulics on or whatever, yeah, they will not stop. They will beat your pressure. Okay, so be very careful. You've got notices, okay, prominently display, and also have safety people present as well if you are going to work in that vicinity. The translating sleeve can be manually moved rearward and forward by manual operating mechanisms, so we can actually move that thrust reverse sleeve manually. And we've got one in a hanger back here at Schoon. We get a big old, just a bit, little drive, and we spin it around by hand. It takes forever, all right, but you can move it back manually. It can also be activated by power, as said, when functional checks are called for. Timing and completion of deployment and stowing can be accomplished in the hangar. I'll have to change that, that's the wrong spelling there. Okay, so yeah, you want to, when you select the thrust reverse, you're checking functional, it's actually physically moving. Lots and lots of screw jacks usually round about the engine. Again, if they're misaligned or damaged, that can cause it to stick, to expose the cascade vane. So again, take your time with that. Record how long it takes to open, because you want all thrust reverse systems should be activated at the same time and move at the same amount of speed. Because remember, if you get maybe one engine working, one engine not working, then you need to cancel the other circuit, which will do automatically. So we prevent differential braking as thrust reverse is activated coming down a runway. Big one, yeah, all safety precautions must be observed. The bigger the engine, the bigger the damage. Okay, so for example, when power is removed, the translation cowls, the C cowls, they will close on their own. They're designed to close on when the power is removed. And if you're inside there, it's going to cause a few problems. All right. Okay. All right. Where are we? Right, if you just bear with me 2 seconds, gentlemen, till I get, where am I? Right, if you just have a read your notes for 2.
ब्राजो
मेरो-
गएको
असला
हाम्रो पनि गएको हो साथी ए सोन
असला है के
ओ सोनदीप मेरो यार यो फोटोहरू नि यो भिडियो हाने के भएर हौ
Just move my cat away. Right.
गरेको भएन भने यार फेरि गर्दा नि भएन
I was just checking the internet as well. Everybody seen the PowerPoint so far? Yeah, nobody's internet falling out. All good yet?
Yeah, all good.
Yeah, just moving. I've got a pet cat was moving about here. Just throwing the cat out the door. Oh, falling down there. He was moving my books about. Right, okay, where was it? Yeah, safety precautions. Be very, very careful around all these stuff, guys. They will hurt you, okay? Same with thrust reverse buckets and all that sort of thing. Anything that moves under pressure is going to win. You won't win. Okay, so be very, very careful. They will not stop if your hand or head is in the way. In other words, it's going to hurt, okay? And worst scenario, be very, very careful. Okay, as I said, sea ducts can be opened hydraulically as well to gain access to the core engine. Entry to the sea ducts and the core engine should be carefully monitored. Again, hence why you have safety people. If you're going to do anything on an engine, it's always better to have somebody there as well as safety. I had an occasion where on one of the fight aircrafts we had to go down and check the engines, go down intakes, a lot of water, and you're supposed to be 2 people. Well, one person went on their own. They went down the intake, and then it was a big noisy day. Somebody went past the aircraft, saw the intake cover was off. They put the intake cover back on. Didn't realise there was somebody down the intake of the engine. Okay, so the person couldn't get back out, but because they hadn't told anybody there, they didn't know they were down there. So it was quite funny in the end. But all right, who have we got there? Going back. All right, here Rams, you say? Okay. Right. Let's go back in there. Failed to carry out the work in accordance with the maintenance manuals will or could have very seriously damaging and potentially fatal results, and that has happened. Okay, so don't get complacent. Don't think, oh, I'll be okay. Just get stuck in there. Keep it safe. All right. You can replace metal, but you can't replace flesh. So you have been warned. Read the manual and stay to it. Okay. Double check for now. Yeah, that's fine. That's fine. That's fine. All right. So occasionally, if I'll go back one, sorry. Yeah, sea ducts, done that one. Occasionally, again, the mounts, very, very careful with these ones. What you've got is a combined nozzle. Where they fit into positions. So it's just showing you how they fit in on the stands and mounts. Again, you've got threaded bearings, external gearbox mounts, positions A and C, employed for engine propulsion system. So very, very careful. There's a little typical pin that goes in. Okay, so again, this is for the rear support on the stand. So when you fit in these, you take time, watch your fingers, make sure the fingers are out of the way. But there's not actually a lot that holds them in when you go back into the stand. So it has to be pinging there, it's not gone. All right. Just different positions of how they fit on. Again, all specific to the engine you're working on. You might have a simple sling like that. It might be a horizontal one that goes back the way. It all depends on the type of engine. Again, there will be fittings for the actual lifting the engine, and there'll be fittings for the actual with the trunnions and the mounts all fit in as well. Okay. All right. So exhaust collector and body and strut fairing. Now the exhaust collector is attached to the rear engine turbine case flange by simply a series of bolts. Again, it's designed to exit engine exhaust gases and streamline the aerodynamic configuration of the rear portion of the strut. Some engines where the cold stream and hot stream exit together, that can be classed or known as a common nozzle assembly, or abbreviated to CNA. And the following from me, oh sorry, so that was that one. For the exhaust, that's pretty much it for those ones. Let's just double check. That's there. All happy. Yeah, it's not too bad there. Too bad. Okay, just make sure there's nothing covered. These are all new PowerPoints. All right, so any questions on those parts? We'll finish off on flexible pipes, nice and easy. Okay, and then we'll get on some revision after this bit. So, flexible pipes, you've got your engine fitted to your aircraft, you've got lots of pipe work there. We have a lot of flexible pipes like your LP feed pipe, your hydraulic pipes, any sort of pipe that's flexible. We need to know some information about it. Okay, so some of the information you should find, there's basically two types. You'll find those with detachable end fittings and those with solid fittings. So what you're going to find in there is date of manufacture, date of last test, drawing number, part number obviously, serial number, and also an inspector's stamp. Okay, bits of information you need to know: one, it's the right pipe, when it was made, and we make sure we put it in the right position. So, description of one, it's basically two kinds. You've got those with detachable end fittings, all right, and those are issued by manufacturer, which are of piece. You can make those. I used to work in the ROV industry offshore. I used to make these pipes, and I could have saved the aircraft a lot of fortune. But yeah, that's pretty much it. The hose material is either synthetic rubber or Teflon. If you ever do Module 16 piston engines, we cover a lot more in the terminologies of these pipes as well. But synthetic rubber or Teflon. The synthetic rubber pipes reinforced with cotton or metal braid, and depending on the pressure that the pipe has to withstand. There's a rubber sheath on the outside to protect the braiding. And then braiding outside, well, you've got fluid moving through, so you might get static. So the braiding also helps as a reinforcement and helps as also grounded to earth too. Okay. Teflon hoses made of tetrafluoroethylene resin, again strengthened and protected by stainless steel braiding, and Teflon will generally withstand higher temperatures and pressures than synthetic rubber. End couplings, we've got lots and lots of different types, but usually made of steel or light alloy, depending on the installation. End fittings grip the hose, including internal braiding, ensure a leak-proof joint. The hoses that are carried in a fire zone are required to be fireproof, strangely enough, an engine bay, etc. So you're going to replace a flexible hose, a few basic checks you have to carry out. So pre-installation checks, nice and simple. Is there any damage? If you might get one from stores, well, it's from stores, it should be fine. But don't just assume any component you get for an engine or an aircraft is ready to fit. Take out the box, take the wrapping, physically check it, does it look okay? There's a few checks with the hoses we need to check as well. It could have sat in stores for a long time. Maybe the package has been ripped or cut, so it could be corrosion end fittings. If there's corrosion end fittings, well, what's it like on the inside? Cleanliness, and tell as fast as possible. Sometimes what you can do is actually flush the pipe through with some clean fluid of the same fluid it's going to be attached to. So again, flush it with the system fluid. Verify the part number, because some pipes might have the same fitting, the same size of connection, but they're for a different system. So the pressure testing can be different and that sort of thing. Pressure test if specified or if in doubt. Now, normally you're not going to do that because they should have been tested before they've got to the aircraft. Okay, but if you're in doubt with anything, send it back. If you have a facility there to pressure test it, that's fine. And some of the pipes, again, we used to make the offshore. We get what's called an inner pack, basically a hydraulic pump. It's a hand pump. We connect the hose up with a gauge and we test it to a specific amount, usually 1.5 times the working pressure. So it's a 3,000 PS pipe, be 4,500 PSI. So we used to make these pipes, pressure test them, and what you do is pressure test it, build up the pressure, and leave it as a specified amount of time. And the pressure should stay there. If it starts to fall down or decrease, then obviously there could be a problem with the pipe. So good things to observe. Following points when fitting flexible pipes. Ensure the pipe does not come into contact with other parts of the aircraft or engine and allow for pipe flexing. Also check for correct routing. Right, make sure it's not touching something, you've not twisted it. Common sense also there. Do not exceed the manufacturer's minimum bend radius. So again, the pipe should be ready to fit, as in the design fit. You have to make a pipe up. Well, that's not normally that. They must be airworthy checked. You can't just go make your own pipe up. But again, there could be a modification. The new pipes come out, but it's not quite right. If you bend the pipes too much, well, it puts too much stress on it. So again, it must be right to do the job. Straight hoses must be good one to highlight here, must be 3% longer than between the ends of the component. In other words, the pipe's got to be 3% longer than the distance where the join to the join is. The reason for that is, if it's the same length, what happens when there's heat and expansion, the fuselage will expand and that will stretch the pipe. So by having a 3% longer pipe, that allows for a little bit of play to allow for expansion, thermal expansion. If lubricant is used in the threads, ensure that it does not enter the pipe unless it's the same fluid, obviously, as what's going in. If it's a fuel pipe, fuel, usually petroleum jelly or some petroleum oil. Again, if it's an oil pipe, just use the same oil. If you need to put lubricant on it. Again, your maintenance manual will specify what type to be used in there. Ensure the hose are not twisted and support the hose while tightening. Yeah. It could be quite a large hose, so I mean, as you're tightening the nut up, also use the 2 spanner method as well. But the best thing to do, if you're fitting a flexible hose, put both ends on, loosely fit them, make sure you've got orientation. Once you've got orientation correct, now those lines on the pipe can also help show you if there's twisting, not twisting. But always best to loosely fit everything first. Don't tighten one end and then try and tighten the other end. Loosely fit, get the position, and then maybe finger tight and then finish off with the correct spanner. Only use the approved hose support guides and clips at the correct intervals. Use packing between the hose and clips. Some clips are pure metal, some clips are the metal with the rubber inserts in them as well. Again, make sure they are all there. Once you've fitted it, carry out the system function and leak test. If it's part of the aircraft fuel system, then a flow test must be carried out. You'll do a static leak check and you'll do a dynamic leak check. In other words, hydraulics, pneumatics, fuels, oils, etc. You'll connect everything up, you'll switch everything on, you allow maybe the fuel to enter into the engine or wherever the component is. Is there anything dripping out straight away? Is there any point to start the engine if you find a leak? If you find a leak when it's static, go and check it, tighten it up. If it tightens up, great stuff. If it doesn't tighten up, maybe a seal has been nipped or has maybe damaged the threads or something. Again, what you would do is isolate it, take it off, check it, and refit or replace if required. Sometimes you get new parts, they just don't work. You just have to, don't assume that a brand new part will work first time. 90% of the time it will, but you do get some new ones that just will not be ready. Carry out a bonding test. What do you mean by a bonding test? Anybody know?
Yes.
Okay, what's a bonding test?
Electrical bonding test.
Yeah, electrical bonding test. What are we trying to check there?
It's like the different charge between the different parts of the aircraft.
Yeah, because you got
To equalize the charge between different parts of the aircraft.
yeah. What's it? If you got any fluid moving in a pipe, you get static buildup. Yeah, so you're going to reduce the charge. Now, obviously, charges, electrical charges, and fuel pipes. You don't want that. The fuel system has additives in there to dissipate the charge. But if you've got fluid moving, even water in a normal pipe can cause static. So by having a bonding lead between pipes, we can check the resistance. Okay, it should be as low, very low as possible. Again, the figures will be given in a book. It should be as low as possible. If it's high, then something's not quite right. Yeah. We'll come on bond later on. Wire lock the pipeline. Yeah. So you connect it up, hand tighten it first, make sure everything's in the right position, fully tighten it, and then you wire lock it. If you're pretty confident, just go and wire lock it straight away. If it's an awkward pipe, you need to leak check it first, then do that, then wire lock it if it's quite hard to get the wire locking. But normally, even myself, if we're fitting flexible pipes, we just go and fit them, tighten it, wire lock it, and then go and check it, because it's just usually 9 times out of 10 it's fine. If it starts leaking, oh well, we'll undo the wire locking and redo it again. You know, it doesn't take long. Once you've all done wire locking, it comes very easy. So installation, I managed to colour these in your book. So look at this flexible hose here. So A is correct. We've got minimum length is 3% greater than the distance from this end to that end. So it allows a bit of thermal expansion. If you make it exactly the same length, then to an extent that could stress the pipe. And as you can see here, they've connected one end, but as they've tightened the other end, it started to twist the hose, which is unacceptable. So the lay line can help you identify if the hose is twisted or not. Okay. This side, we've got a loop going here, going to another union. Now, before you do that, this is correct, this is incorrect. Why is this one incorrect? So what's wrong with this one? It's got a loop on it, it's connecting there. So what's wrong with this pipe? The lay line's fine, both lay lines are fine, but so what's the difference between this one and this one? Yeah, it's quite a tight radius, and also this part here, that's a lot of stress on it. Yeah, there's a lot of stress on that bend. Not so much stress here.
Yeah, stress.
Yeah, there's a lot of stress at that point. Whereas you've got a loop coming down, going up, and then an elbow connector. So that takes the stress out of this point here. Okay, so although that will work, but eventually movement, stress, that could potentially burst. You know, so that's not very good. Other ones, it's the same sort of thing again. We've got correct and incorrect. So correct and incorrect installations. All right. So again, you've got the join, nice long loop, nice and correct. Whereas here, very short. Okay, so maybe not will work properly. When that bends back and forward, that's going to put a lot of stress as it goes in and out. So again, you won't have to make the pipes up. These pipes will have come ready pre-made. Basically, you're going to fit these pipes. You'll do a pre-use check on it. Make sure there's no damage, they're suitable, the right part number, so on and so on. Some flexible hoses have to be removed at certain flying hours because they're under a lot of heat stress. We had certain hoses, I think it was like 2,000 hours that had to come out. Even if it looked okay, even if it's still working, it had to be replaced. Most hoses are on condition. They will work until they need to be replaced. But certain hoses will have a serial number. If it's got a serial number, that means it's lifed. It's got to come off at a certain point, or usually anyway. So examine used pipes. You're going to time them. Examine the pipe for obvious leaks from the end fittings, and particularly where the hose joins the end fitting. Looking for blisters, so bulging of the actual the hose itself. Puncture the blister. If the fluid, now don't do this when the engine's running, or you've got hydraulic power on, anything like that. If you suspect something, if it's blistered, well, it shouldn't be blistered. It could be external blister, or it might be an internal blister, which the fluid is trying to escape. So again, if you pierce it, fluid comes out, well, it's broken anyway. Reject the pipe. If not, pressure test, and if it leaks under test, reject it. There shouldn't be a blister anyway. If there's a blister, it's weak. There's something wrong. I would just replace it. Aging crack. Now, they consist of very small cracks. If the cracks join continuous line, well, that's going to make one big crack. If the braiding is showing, it is a rejection factor. Okay. Now, with the braiding as well, be careful, but sometimes the strands in the braiding snap and they come off. Well, they can, if you put your hand down it quickly, obviously the strains of the wire can go in your hands and be very uncomfortable. Lots of blood everywhere, not nice. Security, ensure the pipe is locked properly. So we wire lock properly, and make sure you've wire locked it around the right way. When we're teaching our students here and doing practical, when they've got a pipe just in a vise or something like that, and the wire lock, it's nice and easy, lots of space. But when you're in an aircraft, your head's upside down, your arms over your head, you're trying to lock this pipe up here, it can get disorientating. You look at the wire lock and you think, yeah, it's great, I've done it back to front. So make sure righty-tighty, lefty-loosey. So again, always make sure your wire locking is going around the correct way and in the correct mount as well. Corrosion, as it's self-explanatory, examine the end of fittings for corrosion. Light corrosion can be removed, otherwise reject the pipe. Twisting, again, no twist. any twist can be seen by the line, like we saw in the pipe earlier, and run the length of the pipe. If a pipe has a permanent twist, pressure test it. If no visible leaks, you can consider it serviceable. So somebody might have fitted the pipe, and it's been like that for hours and hours and hours. It's worked. It's not damaged. It has been twisted. And you tend to find that rubber pipes, if they've been twisted over a while, they'll stay in that shape. So although not ideal, take it off, pressure test it. Well, okay. Or you might get away with it if you find a twisted pipe. You can redo it, take it off, or slacken it off, reposition it, put it back on. But it's probably worth doing a pressure test just to make sure it is okay. Cut covers, examine loosely for cuts. Any cuts which penetrate the braiding is again a rejection factor. Chaffing, where bits have been rubbing against each other. If the braiding is shown, reject the pipe. If slight chaffing is present, the pipe should be moved, but do not tape it up. Don't put some normal tape up there and think, oh, that'll be okay. Okay, pipe should be removed. Thanks, Jeff, with tight bend radius and any sort of not looking natural, again, should reject the pipe. Okay. Right, before we go into tests, what time on now? 1:15. Right, let's go for our first afternoon tea break. Again, come back in about 20, 25 minutes or so, and we'll carry on with inspection of used pipes. There's a few numbers and bits and pieces we're going to do. Okay, so come back in about. So the bore test must be checked out by one of the following methods. Either visually, as in having looked down, make sure there's no internal damage, there's nothing blocking the pipe, and that sort of thing, or by doing what's called a ball test and a flow test. All right. Now, visually, as I said, look down it, make sure there's nothing blocking, make sure there's nothing there. The ball test, what we mean is we put literally a ball that is 90% the diameter of the pipe. So it's a tenth less than the diameter of the pipe. You put a ball down it, and it should come out with no problem at all. The reason it has to be 90%, not 100%, because 100% wouldn't fit. So 90% of the ball goes down. In all my years that I've worked in aircraft, in 22 years when I was in the Air Force, we never did that. I think we've shown it once at training, but we never have to do it. But be aware that is a facility to do it as well. Okay, so just check that out. Again, with the visual one, you check well visual light as well, a decent torch, make sure that's okay. Flow test, again, consists of passing a fluid through a hose from each end in turn and timing how long it takes to flow out. The figure obtained is then compared with the flow rate given in the manufacturer's manual. Okay, and the bore testing of a hose may include one or all of them, to be honest. You might do a visual check, you're not too sure, let's do a ball check. Okay, we'll do that, seems to be okay. And you know what, let's do a flow test anyway. Again, most of the time, you'll just get a pipe in stores, check for damage, check it's right pipe, all the good parts on it, and then make sure it's clean inside. And if need be, flush it. If it's been sat a while, maybe a bit dusty, it shouldn't be, it should be packaged. But just in case, put some the appropriate fluid down it that's supposed to be there. Again, always have a torch available. Check inside it. And the larger the bore, smaller bore, you won't be able to do that, but certainly be careful with it. So I mentioned bonding. Okay, so bonding. Oh, sorry, is that coming in now? There we go. So yeah, we'll look at bonding. You can see here, I've got some pipes, so rigid pipes connected to flanges, and there's the bonding leads, okay, which connect to their points, and eventually these are all bonded to earth, okay, all good stuff. Types of equipment you get used, you'd be authorised and trained to do it. Used to be what we called B2 guys, the electronic guys or the AVINCE guys were the only ones that used to do bonding checks on our engines. Myself as a mechanical, we weren't authorised to do that. We could do basic multimeter checks and that sort of thing, but bonding was left down to the equivalent of B2s, in our case in the military. But bonding tests and hoses. Hoses are tested for bonding before fitting. The resistance, and this is the numbers you want to make a note of, the resistance should not exceed 0.05 ohms or 0.025 ohms per foot length, whichever is the greater. Okay, so it's closer to the 0.25 as possible. That's less than 0.05. So no more than that. If it's bigger number than that, it's not earthing very well at all. Okay, so it's not suitable. So good numbers to remember there. Bonding is only possible when hoses have a metal in their structure. So obviously some hoses won't have that. However, all steel hoses should be tested between the end couplings and the components of where they're fitted. So when it hits on a flange, there'll be one of the bolts onto there. One of the bolts will have that bonding lead, and check there as well. And again, the resistance should not exceed 0.05 ohms. All right, so pretty much standard. Quite a small number, not a lot of resistance there at all. Okay. These end fittings, these are designed, okay, for say various types of connections, and we use them. I used to fit these to swage lock pipes. We actually build flexible hoses up and show them how to fit these. Again, for purposes of aircraft work, you tend to find you just get the pipe ready to fit. Even in my career, we very rarely replace the end fittings. They become ready to fit. Maybe a union in between, that's different. Maybe a union between a pipe and a pipe, then yes, we would change it to some end fittings. Some of the couplings, possibly it was a rigid coupling, like maybe some of these ones here up the top, possibly inline connections. But the ones that may be attached to the pipes, physically, no, we wouldn't change them. Not often at all. But again, it's designed for cost saving. Clamps are made of red fibre, aluminium alloy, and all that sort of good stuff. And obviously, if you take a pipe off, make sure you're blank. So pipes installed should be checked for the above defects as fast as possible. So we've done all the normal checks, but it's a visual check, a board check, all the good stuff, bonding, and make sure it is okay. However, some additional checks could include the following. Check the pipe is clear of the surrounding structure. So once you fit a pipe, you want to make sure it's the right length. Remember the 3% rule. Make sure it's not touching another pipe, obviously vibration and chaffing. And obviously very crucial that it's not touching any moving controls. So we've got a few limits that you need to remember on this one's just come up now. So the minimum clearances are as follows. So any pipe you fit must be from a fixed structure, must have a minimum gap of 6 millimeters, which is about 1/4 of an inch. Okay. So anything from a fixed structure, so anything's not moving basically. You know, about a minimum gap of 6 mil. That allows for a bit of expansion. From control rods and rigid moving parts, obviously we need a bigger space. We don't want anything to be touching the control rods. So now we go up to about 3 times as much. We're on about 18 millimeters, which is roughly 3/4 of an inch, 0.75 of an inch. So that's from control rods and moving parts. And the last one, any control cables will need even greater because cables can move a little bit, so we need a bigger distance. So now we've gone up to 25 millimeters, which is roughly an inch in distance. So 6, 18, 25, or 1/4, 3/4 inch. So the smaller number, the more rigid it is. The more flexible that something could touch against it, the bigger the gap. Yeah. So make a note of those ones or highlight them and make sure they are okay. All right, just about there. Leak check, yeah, using aircraft power or special test rig, operate system and check for leaks. So before you even start an engine, you might just, as I said before, do a static leak check. Just even open the LP cock, you might have connected an engine and you've fitted or replaced or refitted the LP flexible fuel pipe. And there's seals in there obviously, so you open your LP cock and if it starts flowing out, then you switch off quickly. All right, so always have good, especially in big aircraft, always have good communications when you open the LP cock for the first time, because that fuel will come out quicker than a quick thing. So very careful of that one. Also have buckets ready just in case. Again, if you're happy with leak checks, there's no static leaks at all, then that's fantastic. You might have to put a pressure rig on. You might want a pressurized system if that's just starting an engine. Most of the times you're using an engine, but just in case, you might have to use a pressure rig. Flow test if required. Again, That may involve starting the engine for leak checks as well as flow checks, and especially the fuel flow, oil flow, and that sort of thing. And again, carry out bonding test and ensure you check your couplings are correct and locked properly as well. Okay, so you're looking at tab washers, wire locking, and all the appropriate ones as you see fit. Any pipes you've removed as well, make sure if they're going to be off for a while, put blanks on the end. And remember, on the aircraft side or the engine side, make sure you put the appropriate blanks on as well. Don't leave anything open for too long. If you're just taking a pipe off, it's just for a quick access to go back on, you're using it within the next few minutes, that's fair enough. But if you're going to leave it off for a shift change or you're not going to go back to it, make sure you, and if required, put a label on it and make sure you tell which aircraft it came from, date, and exactly what it is, even a part number as well. All right, so that is pretty much book 3. If you've got the new books, you will have questions page 77 to 79 to carry out, okay? So that is the end of part 3. So what we're going to do now for this afternoon is just recap a little bit. Okay, we'll go through some questions. I'll do some random ones from the book there. And then we'll go back away again and we'll recap again in the morning. So probably finish sort of sharpish today anyway. And then we'll start book 4 later on tomorrow. So any questions from you guys at the moment?